very basic information. Tell me who you are, only then you can answer these questions, versus you don't have to tell me who you are, you can answer these questions. The kind of responses you will get will be very different, right? So you need to have access to this, the methodology of collection of the data, right, in order to truly assess how good this data is. Okay, so we ask data of three things. Are they representative of the sample of some group? Okay, so that means that it is truly random sample, right? So if it is truly random, they produce amazingly accurate results. Okay, just a good example of that. No, I lived in Singapore for 15 years, and they have a very very clean, efficiently run election system. A lot of people think that Singapore is autocratic, but I know that their elections are have a very high level of integrity. Okay, just that the ruling party wins like 90-95% of the seat all the time, right? So people are naturally suspicious that it seems like a North Korea, right, where Kim Jong-un gets 100% of the votes all the time, right? So PAP government, right, in Singapore is kind of really does very well, and then there is no reasonable alternatives there. There is no decent opposition there. Okay, that's the reason why it is does not have the kind of a very competitive political environment that most countries, most democratic countries have, right? And we are all used to extremely chaotic democratic elections that we have, right? So we cannot believe something like that, right? But anyway, so what they do is, so they have these constituencies, and then at the end of the polling time, which is like 8 o'clock in the evening or something like that. I mean, you don't get a holiday for polling, no, by the way. You have to find some time away from your work, maybe during lunchtime or in the evening, and then cast your vote. And at 8 o'clock, then they, because it's a small country, constituencies are small, probably in the thousands only, not like lakhs of votes that we have to count. Maybe 30,000, 20,000 votes per constituency, nothing more, not more than that. So when it is all collected in one place, and then they kind of mix it up, okay, even though they are all coming from various booths, they kind of mix it up really well, and they still use the paper ballot, not electronic and all that. And then they pick 100 ballots out of it and count, and by 9 o'clock or 10 o'clock latest, they publish this result, okay, and say that this in this constituency this guy got, so essentially 67 votes out of 100 votes, the other guy got 25 votes, and there were like 5 invalid votes or something like that, okay. So the election results by 10 o'clock, and that is basically, and then the next day they count the rest of the votes, right, and then you will be amazed at how precisely close the final number is to the 100 number, okay. So invariably, when the whole constituency is counted, the winner will have 60%, 67% of the vote, the loser will have 25% of the votes, and the remaining will be invalid votes, okay. And I have seen this time and again, and I am be amazed at, right, and that time I did not know much about random samples and all that, but now I know that it is because they were truly random, right. So if a sample is truly random, even a very small sample can tell you everything about the whole thing. Who can afford? Yeah. I think what the government does is that they encourage the businesses to let their employees go off. It's kind of a thing, right? I mean, employee can report that I was made to work from like 9 o'clock in the morning until 8 o'clock in the evening. Like you work in a store or something like that, right? And I only got an half an hour lunch break, and I didn't have time to it, right? So I mean, nobody wants to get in the wrong side of the government there. Huh? So they usually give like a half a day off. Okay, so you either can take the morning off or the afternoon off, and then so nobody can really say that I mean, I didn't get it because I was in this kind of a job. There will be other people who are in essential services, like for example nurses, doctors, firemen, or even people who are involved in this whole election administration business. I think they also get some other provisions, such as you can vote by mail and things like that, like mail-in ballots and or are sent to those people. Yeah, it is possible, right? I mean, you can exclude a certain type of population by just making it inconvenient for them to vote, right? Which is precisely what all this gerrymandering about, right? In the US, you must have heard about gerrymandering, right? So they will kind of divide the constituency according to the kind of population that lives there, because there is very clear preference for certain populations to vote certain way, right? And then you gerrymander them in such a way that you make sure that your constituency is enough people for you to win the election, right? You're targeting your base is like mostly white, male, middle class and above kind of people. Make sure that enough number of people are there in your constituency, so that you can win easily. Okay, so that is one way. Another way is that this ballot access, which is what she was talking about, right? Just make it difficult for people to vote in the first place, right? One of the ballot access measures that the Republicans have been pushing a lot is that you need to have a valid ID or something like that, and the ID should be this one only. Right now, I think you can just take a driving license, which is considered to be a valid ID, and then that is enough to vote, right? And they are insisting that you have to bring something else, like such as I don't know, whatever it is, right? Another thing is that you position the ballots in places which are hard to access for poor folks to go and do that, right? So poor families live in some small ghettoized part of the city, and they probably do not have transport, right? Maybe there is only one person who has a car and he has to take the car to work in the morning, and for the rest of the people to commute to anywhere, it is impossible because they can't afford a taxi or anything. The city does not have public transportation system, and the ballot box is like 7, 10 miles, 15 miles away, just harder, right? I mean, even people are just not that keen to participate in a democratic election, right? And then you make it even slightly harder for them to do that, then that they will not vote it, right? So where there is this very large black, less poor, disadvantaged, one of the ways that the Republicans have been, controlling access to the ballot is by these kinds of measures, right? So rather than making more, they will say that no, we have too many ballot boxes, right? Let us remove them, right? Because it is increasing the cost to the city. Okay, so we'll reduce it, and we'll only place them in these kind of places, because if you are the ruling party, you can control all these things, because this is considered to be an administrative thing, right? How many ballot boxes we will place, how many booths you will create, where you will position those booths, all these things are controlled by them. If they can make it harder for, even if they reduce black participation in the election by say 3 or 4%, it could make a huge difference in the entire outcome of the results, right? So yeah, all of them are problems is possible. Okay, so we saw, so for most of the analysis, you don't need to know very sophisticated statistics, right? What you need is very basically this descriptive statistics, right? So they help you frame the issue and to simplify, which always implies some loss of nuance and detail, but they are more than enough for most analysis, okay? The point of statistics is not to do rigorous mathematical calculations. The point is to gain insight into meaningful social phenomena, okay? Statistical inference is really just a marriage of two concepts, data and probability. The power of statistical inference derives from observing the most likely explanation for that outcome. Okay, we cannot be certain, do we have enough data to confidently claim that this is the most likely reason for something. Okay, okay, I just don't want to go into this detail, everybody knows what they are. These essentially constitute your descriptive statistics, and I'm saying that this is more than enough for most of your analysis, right, with quantitative data. They are same. It's just two words for the same thing. Median is different from mean. Yeah. Are you talking about median? Yeah. Okay. So median is the point that divides the distribution in half. Okay. So it's the midpoint. Suppose you have 20 values. What is the mid value, right? What is the value of that middle point of this distribution of 20 values? Okay. So it may not be the mean or average, right?
So can you find the median of a form?
No. You cannot do any of those things, right? We can only do frequency distribution with nominal data, right? You can only count the occurrence of that.
Could you just go back 2 slides? So there were 2 more points.
Okay, I'll just talk about the last one, index. Maybe you guys are not familiar with that's very useful for for visualization, because it's very good for summaries. Okay, so this one, the index, right? The index is a descriptive statistic made of other descriptive statistics. Okay, just kind of think of it as a meta. The advantage of any index is that it consolidates a lot of complex information into a single number. It's a composite number. Okay. When we think of rank, when we then can rank ratings, otherwise simply that defies simply comparison. Okay, so give me an example of an index. Your GPA or a CPI, whatever it is called, is an index, isn't it? So what does it comprises of? What does it consolidate? All the courses, right? All the courses, right? So you take something like over the period of 4 years or 2 years, right? You will take 25 courses or maybe 15 courses or something like that. So you might get varying grades in each of them, and then how do we come up with a number that we can give it to your performance over 4 years, right? So if I list everything, every course, it's impossible. Two students cannot be compared, because student A might have scored well in these courses, student B might have scored well in these courses. Then how do I evaluate the performance, right? If I want to come up with a rank within the class for some kind of an exercise, okay? So I want to, filter the top 3 students so I can give them some award, for example, right? Or I want to filter the top 10 students from BDes so that I can qualify them to be the 5th year MDes dual degree students, right? Or whatever it is. So a company may look at that, I got this 1000 applications, I don't have time to go through these 1000 applications. Is there some way that I can filter the top 20 applications based on some criteria and some say GPA, so that I can only invite them for the interview, right? This is done all the time, right? So that is it. So the more famous, more other indexes are the stock market index, you must have heard of, right? So the stock market index is made up of the performance of some select 50 companies or 100 companies, right? That gives you a good indication of how the economy is doing overall, right? So they will, and then they come up with a number, right? Very specific number. So it's a kind of a comprising so into one single value that actually is easy. Otherwise, it's impossible to compare. You could see, okay. So that is what it is. So there are other indices. For example, you have this economic growth, right? The UN has a lot of index, right? Health index are there, poverty index, and migration has some kind of an index, right? Because it may not be purely made up of one value, right? It could be, say for example, health index of a country could be made up of not just your your life expectancy could be one measure. The another expectancy could be that how many child mortality, for example, could be another one. Maybe the average nutritional value, right? Per capita consumption of certain things, right? What is that? Many things can combine together to create this one easily comparable thing, okay? So that's the purpose of it. So in many cases, when you do the analysis, this index may not be available, because as raw data, you might be like looking at 3 or 4 variables, but then you still want to consolidate them into one single number that you want to compare it across with other things, okay? So you might have to create an index yourself, okay? And you should, and when you create an index, you will come up with some formula to arrive at this index, right? You say that no, I will give life expectancy this value, I will give child mortality this value, I will give nutritional per capita this value, and people can question that why did you assign these values to them, right? Because that we do not have a clear answer for that, right? It is your index. Just like why should the stock market index be made up of these 50 companies? Why not these 50 companies? I mean, there is nothing wrong in coming up with a different thing, right? It is just one kind of a subjective, maybe it has some objective measures also, come up with it. It is always up for revision, okay? Somebody else can come up with a different index for it, right? For example, there is a ranking that these you find in newspapers all the time, right? That IIT Bombay is ranked some 78 or 178 or whatever it is. Some different agencies come with this ranking, but they all have their own different indexes, right? They also create index. For example, that index could be that how many research papers are published in this institution. What is the ratio of local students and foreign students in the student and faculty composition, right? What is it could be about related to employment, it could be related to other things and so on, right? Now, one can disagree with that, right, which is what we have been doing sometimes. We kind of completely reject certain ranking because we are not after the matrices they are counting, right. Say for example, we cannot truly represent, see one factor of most of these rankings is that how diverse the student and faculty population is, okay. Diversity is a huge measure in the US universities, right, which means that it is made up of people from multiple races, multiple geographical countries, multiple states within the country and multiple countries from outside. So, the more diversity they get higher rank, right. Something like an IIT Bombay, we do not have diversity, everybody is an Indian, right. We do not have a lot of foreign faculty, maybe some visiting foreign faculty come in. We do not admit a lot of foreign students into our programs because we just cannot admit enough of our own students, right. So those things are, we cannot compete in these things because they are measuring something, but does not mean that we have to compete with those measures, right. So, indexes are always questionable and can be up for revision, things like that. It is not the same as the actual measurement, right, that comes. So, life expectancy is a measure that nobody can dispute, right, because it is just that in a population what a life expectancy is, that is unquestionable, right. But what do you make of an index from that one single measure in combining with other things is up for question. Okay. So, I am going to give you a link and maybe quickly go through this one presentation that I have come across, which I found some very interesting analysis prior to the process of visualization. Okay. So, this is produced by Northwestern University and that is the link. Provided the document also in Google thing. But I will quickly go over it. Okay, so Edward Tufte I have talked about. He has written these 3 books. The first one is called Visual Display of Quantitative Information. The second one is called Visual Explanation, and the third one I forget the name, what it is called. Beautiful Evidence it's called. Okay, so these are the 3 books. Okay, I think we have all the 3 books in our library. So you should when you find time go and look up for these books. Okay, you got a lot of very interesting examples and visualizations. So in this book what he says is that when we reason about quantitative evidence, certain methods for displaying and analyzing items are better than others. Superior methods are more likely to produce truthful, credible and precise findings. The difference between an excellent analysis and a faulty one can sometimes be monumentous, sometimes have monumentous consequences. Okay. Now, he starts with this example that we are all familiar with, John Snow's cholera map. Okay. So, he goes through kind of dissects it as a case study. Okay. So, the C is cholera, I think it is context. Okay. So, cholera breaks out, this is 1984. So, this is what cholera was: severe watery diarrhea, vomiting, rapid dehydration, death can occur within hours, fatality rate is 50%, killed millions in the 1800s, most commonly occurring places are India, Russia, Europe and North America. Okay. So, I think the C, the second C I am not sure what it is, underlying deficiencies in understanding of bacteria technology, sanitary living conditions. Okay. And the question is, how is cholera transmitted? How can we stop this cholera epidemic in central London? And then the H is hypothesis, right? Cholera is spread by breathing vapors of decaying matter. Okay. So, this was the most agreed upon reason. Okay. At that point of time, most of the medical fraternity believed the first cause more than the second cause. Okay. But Snow was the proponent of the second cause, right? He dismissed the first cause. It is not because he knew that it was not transmitted through the air. Okay. So, because he had this second hypothesis in mind, so what he had to do, the method is this: he searches for correlations between water and cholera. Okay. That is how he set about his task. Look for impurities in water. Okay. And the first cut is that there are no impurities in water visible to the naked eye. Okay. I mentioned it, right. So, that is a dead end. So, if he found some impurities, that would have been enough to convince people, right. The very fact that people did not believe him, in fact, was because there were no impurities in water, right. Now, the second is connect water deaths with water sources. Now, you are in a situation where you cannot see any impurities in water, there is no way to show impurities in water. Then what do? The next best thing you can do is connect deaths to water. Okay. Obtain the list of deaths from the General Register Office, convert the list into a map. Okay. And that is what he did. He did this, located and then found a strong correlation of cholera victims near the one specific pump. Then okay, so we saw all these things, handle removed, deaths started to plunge. So, we also saw how other modes of representing the same data could have led to faulty conclusions, right, or no conclusions at all. Aggregates, for example, right. So, now the same data you are looking at 3 different views of quarterly data, physical years, calendar years, right. So, the same data, but when you are presenting it with different views, right, it may present different picture. So, there is hypothesis, collection of data victims, convert the data into a map, communicate with authorities, response, app ending. Okay. Now, another example, this is an example that we have not seen, but dealt in a lot detail in the Tufte's book. Decision to launch the space shuttle Challenger January 1986, right. You all know about this tragedy, right. There was this Challenger space shuttle that was launched in 1986, and for the first time there were the crew was entirely made up of civilians. Okay, civilians who were selected specifically for this mission, and of course, they went through years of very rigorous training in order to become astronauts. But the story here is that anybody can go to space, okay, and that NASA and the US government projecting is that the space is a reality for common folks and not just very specialized scientific community, right, and extremely trained, highly skilled astronauts, right. So, among the mission crew were people like firemen, there was a elementary school teacher in that, right, who all went through some very competitive selection process in order to prove their fitness and their basic qualifications in maths and science, etc., and all that. And this shuttle crashed, okay, immediately after launch, a few seconds or a few minutes into the launch, it just burst into and then it died, everybody perished. And then government constituted a committee to investigate the reasons for it, and then they found out there was some major flaws in the assumptions that they made, and there was a lot of miscommunication of this important findings across 2 key agencies that were responsible for this mission. Okay. So, there are 2 companies that were involved in this. There is NASA, which is the body that does these missions, and there is this Thiokol Martin, okay, which is the rocket company. Okay, it's a company that is that produces the rocket and then puts the the Challenger in the orbit, right? So the space shuttle segments of the booster rocket. So what they found was that there is this segments of the rocket, right, which propel the Challenger into different heights, right, and they all fall off after some time, right? When they are fully exhausted, they will fall off, and then the next stage rocket fires up, and then it pushes it even further and so on, right? And there is something called the O-rings that are like the what is it called, the washers, right, in between the stages, right, made up of some kind of a rubber. And what they found was that these O-rings had failed, okay, and which caused the rupture, which caused the fire, and which caused the explosion of the rocket. So what was found eventually was that all previous launches had occurred at temperatures of less than 53 degree Fahrenheit. The forecasted temperature of the launch was 26 to 29. Okay. So on the day this Challenger was set to launch, the predicted temperature was very low compared to what the test, when the tests were done. Okay. So now these are not missions that are taken lightly. Yeah? So they do multiple simulations. They send actual rockets with the actual payload and everything, without the people, of course, just to make sure that they got the right kind of a payload and every parameter is checked and all that. Okay, and only when they are completely satisfied, they will put the actual crew and then send this rocket up, right? So whenever they did this test missions, right, without the crew, they did it at temperatures when it was 53 or more. Okay, so they never had any data. And what they do is, after these launches is completed, they go and retrieve the fallen parts, bring it, and then they study them, the rocket segments, to see where the damages are, what is the problem, everything is went on okay or not, and things like that, right? And so they have collected very meticulous data about the previous launches, right? So this is the engineers at Martin Thiokol, MTI, and then the NASA officials, right? So what Martin Thiokol did was that they first refused to send the rocket. Okay, they said that we do not have any data about any of our test missions for this kind of a temperature, right? It's really cold. Whatever test missions data that we have were about temperatures much higher than that. Okay, so we are recommending a no launch. Okay, NASA was not very happy with it, right? Because by then this whole thing has become a very political affair, right? Because it was about the country which is in the cusp of this very major scientific achievement. President was personally involved with it. A lot of news had happened in the newspapers, television programs that broadcasting this whole thing live. Everybody was looking forward to this event and so on and so forth. And NASA was in a bind, right? They said, no, I mean, we cannot not have this read. There was just too much of expectation of the country behind this event. We have to somehow go ahead with our plan, right? If we cancel it, it will be a big disappointment for everybody, right? It will appear as if we have failed in our mission, right? And that it will reflect on our success story, etc., etc. I am sure a lot of non-scientists intervened and put pressure. Okay. And how did Thiokol Martin communicate its no recommendation? Okay. And they did it through a bunch of slides like this. Okay. 13 slides were faxed from MTI to NASA, which looked like this: highly technical, impossible to understand if you are not familiar with the field. Okay, so this is one of them. So this is the damage history, blow by. This SRM 15, SRM 22 are all the test mission codes. Something like this. So it's like they were not even worried about that it's a very important recommendation that we are trying to communicate, and we have to put it in a manner that very precisely points out the reason why we are recommending a no launch, right. So, final recommendation is the O-ring temperature must be greater than or equal to 53 at launch, development motors at 47 to 52 with putty packing at no blow by, SRM is worked at 53, best simulation, project ambient conditions to determine launch time. How would you respond to this argument? Was this an effective argument? Okay. It was clearly not, right, because the MTI recommendation was so vague that the NASA did not take it very seriously. Okay. They did not understand the implication of the gravity of the problem. So, obviously, they said that it is appalled by this thing, and then there was a lot of back and forth, and finally, MTI gave into the pressure and said that okay, let us go ahead with it, we will do it. So, post analysis, the committee that was formed to investigate this whole thing, they also looked at the communication failure, right. So, there was some technical failure, but more than the technical failure, it was the communication failure that led to this disaster. Okay. And famously, Richard Feynman was member of that for the investigation team. It was broadcast live, and some of those hearings, quote the investigation hearings, right, are available on YouTube. Just look it up. They are very nice. In fact, Richard Feynman at one point even demonstrate how the O-rings failed by having a glass of water, having samples of the O-ring and then putting it on the water. Okay. And you can find out that how excellent communicator he is, right. And despite the complexity of the science behind it, he was also talking to the American people, right, through this televised program, and he was trying to explain what happened with the Challenger launch in very easy manner that everybody could understand it. Okay, a careful analysis of the flight history of O-rings performance would have revealed the correlation of O-ring damage and low temperature. Neither NASA nor Thiokol carried out such an analysis. Consequently, they were unprepared to properly evaluate the risks of launching the 51L. Okay, 51L is the actual code for this mission, Challenger mission, in conditions more extreme than they had encountered before. Okay. Now, what Tufte did is that he said, okay, if I were to communicate this data, what would I do? Okay. So, he took the data from the 13 slides and then through an iterative design process came up with a visualization to communicate this key insight, and this, if it was communicated like this, then it would have led to a different conclusion. Okay. The NASA would not have launched it on that day, they would have cancelled it, and this disaster would have been completely averted. Okay. You could see that initially he was going for iconography, he was trying to do this. Then successive. So, you can see these are number of the history test flights, right, where the erosion was happening, where it was not happening, at what temperature they were having. Okay. So, there are pros and cons of this display. Then what he found was that there are three measurements that are here. Okay. There is temperature, there is erosion incident, and there is something called a blow by incident, right. Now, they were very difficult to compare and come to some understanding, right. So, he created an index. Okay. He called it a damage index. Okay. So, it is some combination of temperature, erosion and blow by which results in the damage index, right. Now, he was able to directly compare all the missions, right. All the test missions can be now ranked based on at what temperature it was happening. Okay. So, he finally arrived at this. So, what he was essentially doing, that he was taking the data, raw data, and then he was deriving some other data with it, right. So, you can see original data, derived data, okay, and then creation of the index. Okay. So, this derived data and the index is what Tufte did on his own. Okay. You can question whether this index is whatever formula you used behind arriving at this index is, but then it was very useful. Okay. The realization that index is the most useful tool here is the key insight here. Okay. You can see that the comment section very clearly say when was this happening? Okay, most erosions, any flight blow by, this is the highest, right? Deep extensive erosion, O-ring erosion, and these are the type of thing. No, so you notice that some of this at the higher the temperature, the less erosions and less damages. Okay. Then he started to plot this on this thing. So he had this temperature on the x-axis and the index on the damage index on the y-axis, and then it immediately reveals the pattern, right. He was able to pinpoint where was the damage happening, at which temperature the damage was happening, and then how it was gradually reducing. Sorry, it was increasing, right, as the temperature was lowering, right. You could see that there was a pattern there, right. And he also highlighted the temperature at which the proposed launch was going to happen, when it is scheduled. Okay. So he tried a few other, I think, and then so this is his methodology. Okay, defining what is the point of this display, what am I trying to communicate, what is my message, how do I make my message clear. It is very clear, right. The key message that he wanted to communicate was that at lower temperature more damages, okay, and at the temperature which is the lowest when it was any launch has, at the temperature on which the proposed launch is planned, we do not have any data at all. Okay, we only know that as the temperature gets lower, the damages increase, okay, based on the data. Okay, so simple. So should I use table? Should I use text? You should use a graph or a visual. You tried all of them. You could see. What design principle lead to quick cognitive processing and effective communication of my message? Then of course you will use a software. Excel spreadsheet is what I think you used it. You could use other tools, right, that help you communicate this. Okay. So this is the process, right. The steps are very clear. Okay, so that is the end of this. We'll put up these slides for you to take a look at it if you want.